All right, guys. What's up? We're gonna continue on with our last unit. I can't believe it is already our last unit of the year in terms of Algebra 2. Pretty simple unit, to be honest. The worst is behind us. I definitely thought Chapter 13 was difficult. Chapter 12 and 13 was difficult. This unit is pretty simple, okay? 0.9 measures of center, spread, and position. Students will be able to find measures of center, spread, and position. Your homework is page P27, numbers 1 through 5. P27 is like, if you're using a textbook, it's like the pages before like page 1. It's like the first chapters. It's like the preliminary chapters. So you'll find it there. If you can't find it, I definitely am going to attach pictures of your assignment on here, so no worries on that front. Okay, all right, we're gonna move on. Statistics, we're talking about stats. Stats is the science of collecting, organizing, displaying, and analyzing data in order to draw conclusions and make predictions. So it's the idea that we're gathering info, and then from that info we're gonna make like a fact. Now there's two types of main things that we want to focus on today. The first thing is called a population. It's everything. It's the entire group of interest to a statistician is called a population, right? For example, everybody at Bolsa Grande High School, like all the students would be a population of students, right? Yeah. If I want to narrow it down, all the Algebra 2 students, that's still a population. That's all of them that I care about. Okay. I'm going to skip ahead just to see what okay. So I didn't talk about it yet. Okay, so yeah, that's called a population. Sorry about that. Ignore that weird noise I just made. A population. The next thing is a thing called a sample. Oh, actually, I do mention it. It just got cut off. So a population is everything, right? A variable, it's not like your X and Y. Well, it could be, but it doesn't have to be like that. It's a characteristic of a population that can assume different values, like ethnicity, religion, first language. It's a thing that can change. It's a thing that can change your. That can change within the population, like how much money you make, IQ level, grade. It's the thing that changes in a population. It's the thing that we're trying to measure that changes. Okay? So, yeah. Alright. Data that include only one variable are called univariate data. Like, for example, if we're doing, if I'm doing the population of Bolsa, like there's a lot of variables there, right? It could be your ethnicity, it could be what grade you're in, and so on and so forth. But if I narrow that down, and let's just say I want to focus on what grade level you are at, that's univariate data. Like I'm focusing only on that one specific data. Okay? So univariate just means one. I'm focusing on one. So sometimes doing a population is really difficult. Like the population of Bolsa, there's like, I don't know, 3,000 students at Bolsa. Maybe going around and like asking every student about what grade they're in, or what math class they're in, or you know, me collecting data like that might take a really long time, and it's not sure that I can ask every single person. So most of the time doing a population is not realistic. So what we do instead is we do this thing called a sample. Okay, and a sample is just a part of the population that represents it, okay? Instead of asking all 3,000 students at Bolsa, which is really hard to do, maybe I'll ask 50 students or 100 randomized students, okay? So here's a little picture of it. Population is everything, and then sample, like population is everything, and sample is like part of the population, okay? All right. Next thing that we want to talk about, univariate data are often summarized using a single number. So univariate, we want to use a single number. Measures of average are called the measures of center and central tendency. And then some of the most common measures is the mean, median, mode. And that's what we're going to focus on today. Mean, median, mode for the most part. Okay. So yeah, we want to do this thing called a center measure of central tendency. We want to focus on mean, median, mode. You guys should already know how to do this. So I'm going to go through this really relatively quick because there is a lot of slides. The mean. For the mean, this symbol right here means mean. This symbol is read as mu. M-U. Mu. Okay, mu is mean. We can also use this thing called X bar. This is read as X bar. And that can also mean mean. So mean can be mu or X bar. It's just a symbol for it. These X1, X2, all the way to Xn, those are just what numbers you have. And then n is the amount of numbers. So you guys should already know that. To find the mean, you just add and divide by however many numbers you have. That's essentially what that formula is talking about. Okay. Like I said, x1, x2, xn, those represent essentially like each number, right? Each number. If I were to go around finding the average age of Bolsa and I do a sample of 50 kids, some might say 12, 13, whatever, 17, 18, whatever, right? Those would go here, like the 18 plus 17, like whatever numbers I'm getting, I'm adding there. Okay. The median, you should already know it. It's the middle number or the mean of the two middle numbers once the set is in numerical order. So you just put your numbers in order and then find the middle number. And then the mode is the numbers that appear the most. A set of data can have no mode, one mode, or more than one mode. Okay. You can have no mode if all the numbers occur at like the same time. Like if I have a list of like 4, 4, 6, 6, 8, 8, this would be no mode. Right? Because everything occurs twice. If I have a list of numbers like, I don't know, like if I do like 4, 4, 4, 6, 6, 8, 8, then obviously the mode would be 4, right? That'd be one mode. And then more than one mode, you can have data that's like 3, 4, 4, 5, 6, 7, 8, 8. The mode here would be 4 and 4. You can have multiple modes because those happen the most. Cool? Cool. All right, we're moving on. Just going through this real quick. I want to find the mean, median, mode. Okay, so my first step is I'm usually just going to write the numbers in order. So 10, 20, oh, totally forgot 15. 15, 20, I think 25. What's next? 30, 35, 35, 35, 40, and 50. Okay, so I'm going to do the mean first. And you should already know how to do the mean. You just add all those numbers. 10 plus 15 plus 20 plus 25 plus 30 plus 35 plus 35 plus 35. So just be careful that you don't skip a number. That's really important. 50. And then you just divide by however many numbers we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 numbers. So my mean here, I'm just going to use my calculator real quick. 10 plus 15 plus 20 plus 25. 30 plus 35 plus 35 plus 35 plus 40 plus 50. Yeah, like sometimes I go through this really quick and skip a number. So I got 29.5. Right, I'm just doing the math real quick. Okay, next I want to do the median. Median is pretty simple. Median is just find the middle numbers. So I'm going to use this list right here. So boom, boom. So I'm just marking numbers off and trying to find my middle. So do you see how the middle is both 30 and 35? There's two numbers in the middle there. Okay. If there's two numbers in the middle, what you're going to do is you're going to add those two middle numbers and divide by 2. So it's 32.5. That's your median. And finally, your mode is just whatever number happens the most. So it's 35. There's 3 35s here. Okay. For the median, if there's only one number in the middle, then it's that number automatically. Okay, you don't have to divide by 2 or add and divide by 2. If there's one number, then that's that number. Okay, moving on. I'm pretty sure you guys could do this, so I am going to skip this. This is just finding the mean, median, mode. I should just do it. So I'm just, like always, my first step is just to write the numbers in order. Okay, those are my numbers, so let's make sure I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 9. Okay, so those are my numbers that are in order. Okay, so the mean, you guys should know how to do, so I'm doing 16 plus 18 plus 20 plus 22 plus 22 plus 24 plus 24 plus 32 plus 46 divided by 9. I believe there's 9 numbers, so 16 plus 18 plus 20 plus 22 plus 22 plus 24 plus 24 plus 32 plus 46. So it's 224, so 224 over 9. So I'm getting about 24.89. I'm just going to round 2 decimal places. So around 2 decimal places. The median, just finding the middle number, so I'm just going to mark, boom, boom. So I'm like that. So my middle number is 22. I don't have to add or add and divide by 2 because that's just it. My mode, what number happens the most? 22 and 24 would be my modes because those happen the most. Cool. Moving on. All right. The next thing that we want to talk about is this thing called a variance. It's the measure of how far data is spread apart. So here are some examples. So my first list is all 12s. Notice that the numbers aren't spread apart. They're all the same. So my variance is 0. Here, it's 12, 12, 12, 12, 12, and then 13. There's only one small change. Because of that small change, the variance is 0.0156. Like, they're not all the same, but there's only one small change. So the variance changes. And then let's check this out. 12, 12, 12, 12, 1,000, 13,013 has a variance of 1,353,248.29, and it's because like the increments change it like different because all the numbers are 12s except for this one really big number that stands out. And because that number stands out so much, the variance gets really big because it totally goes against the trend in the pattern. Okay, that's what a variance is, how close they are. What is this? Day 2? Nope, skipping it. You guys can do that on your own. Okay, the range. The range is the difference between the biggest and the smallest data set. So here's an example of range. Let's say I have 12, 13, 24, 29, 29, 11. Okay, so I'm looking for the biggest and smallest numbers. So my biggest number is 29. It doesn't matter that it happens twice. Like 29 happens twice, it's still the biggest number, and then 11. So I do 29 minus 11, and then it's 18. My range is 18. Okay, this is the formula to find a variance. What I want you guys to do is notice that this is population variance. This weird little symbol right here, it's not a 6, it's called a sigma. And this is sigma squared. That's the symbol for variance. Okay, and then you have this kind of complicated formula. Notice here, this is mean, right? So you're taking all your data points, x1, x2, and so on, and essentially what you're doing is you're subtracting from the mean and squaring it. And then you're adding all those up together, and then you're dividing by n. The formula looks really complicated and convoluted, but let's just copy it down and then we will definitely try it out, okay? The next thing we have is this thing called a sigma. This is called standard deviation. So without the squared, this is standard deviation. And now this is a standard deviation for the population. Okay, there's 2 types of standard deviations. There's 2 types of variance. One variance for population, one variance for sample. One standard deviation for population, 1 standard deviation for sample. These are for your population. You have to be really wary about what it is. Okay. Are we dealing with sample or population? That's kind of the big thing here. Now, for standard deviation, it's actually really easy. If you notice this right here, inside the radical, that's the variance, right? The standard deviation is just the square root of the variance. Like this formula inside here is the same as this top. You just square root whatever you got for the variance. So standard deviation, the variance is hard to find, but once you have the variance, you square root to find the standard deviation. So so the previous two formulas are for population variance and population standard deviation. We kind of talked about that. Moving on. Okay, so here we're going to talk about sample. The only thing different is now we have an S. S is for sample, right? But this is the variance, so it's sample squared, or it's S squared, so it's the variance, right? There still is squared here, right? The only difference is, notice the top stays the same. Yeah, you have X bar, but remember that still means mean. Like it's the same thing as mu, like it's the same thing as mu. So nothing changes. The only thing that changes is the bottom, instead of being an N, like here it was an N, it's now an N minus 1. Same thing for standard deviation. Standard deviation, once you have the variance, you just square root to find the standard deviation. Okay, so you take your variance, square root to find the standard deviation. Okay, here are some cool things. I would just copy it down. I'm not going to talk about it, so I would pause the video and copy down. These are just your steps, pretty easy. Okay, and then we're just going to go through some problems. So here, find the range variance standard deviation for the sample from class A, okay? So the first thing I'm going to do is I'm going to find the range. That should be really simple. The biggest number is 92 minus the smallest number, which is 76, so the range is 16. Right? Tell me it's the spread, right? Next, because I'm doing sample, I'm going to focus on S. I'm going to find the variance first. But to find the variance, I should find the mean. Mean by now you should know how to do. 85 plus 76 plus 92 plus 88 plus 80 divided by 5. So that's the mean. So using my calculator, 85 plus 76 plus 92 plus 88 plus 80 divided by 5. So I get about 84.2. So that's my mean. I know it doesn't ask for mean, but you need the mean to find variance. Okay, let's do variance now. So the variance, you're going to do it, it's pretty simple. You take your first number. The numbers don't have to be in order, but if you want it to be, you could. Take your first number, which is 85, minus the mean, which is 84.2. You square it. Then you're going to plus the second number, which is 76, minus 84.2. And then you square it. Then you take the next number, 92. And remember, you're just taking all your data points and subtracting them from the mean. Square it. Plus 88 minus 84.2. Square it. Plus 80 minus 84.2. Square it. Okay, so we're going to start off like that. So, sorry. In hindsight, I should have done this. I should have done this by earlier, but it's all good. You guys get to awkwardly hear my voice while I enter some numbers in, which is so fun. I know how excited this is for you. It's actually pretty hard to enter numbers correctly and talk. Probably sound like a mad person, but it's okay because I'm on my last number. All right, cool. So I got 160.8. By doing all that, I got 160.8, but that's not it. Remember, the formula tells you, because we're doing sample, right? We're doing sample. We need to divide by n minus 1. So I'm going to take 160.8 and divide it by n minus 1. N is how many numbers we have. We have 5 numbers, right? N is equal to 5. So 5 minus 1. So that's essentially 4. So my variance is 40.2. This is my variance. Okay? That is my variance. Next, I want to find my standard deviation. I'm just going to write SD for standard deviation. All you have to do is you take the square root of whatever your variance is. So square root of 40.2. Which is 6.34. And that's it. You're done. Nothing too crazy there. Cool? Cool. Alright, we could do number 12 or this example, but I'm not, so I'm just going to skip it. Yeah, I'm just going to skip it. In your homework, it's going to ask you to compare the two. I should actually just do this. It's going to ask you to compare the two data, like numbers, I believe 4 and 5 is going to ask you compare two tables. Like you're going to have two tables and you're going to do the standard deviation and variance for one table, standard deviation variance for the other table. I'll show you what I mean. So range is 98 minus 68, which is 30. Which is 30. My mean, okay, 75 plus 85 plus 95 plus 98 plus 68. Okay, 75 plus 85 plus 95 plus 98 plus 68. So I got 413 divided by 5. So it's 82.6 is my mean. And then I'm going to find my variance. And once again, it's a sample. So just doing it real quick, 75 minus 82.6 squared plus 85 minus 82.6 squared plus 95 minus 82.6 squared plus 98 minus 82.6 squared plus 68 minus 82.6 squared. So I'm just gonna find the top part first. I always do it one step at a time, to be honest with you. Like I said, it's good to do it by hand. Yep, this is more awkward when I don't talk. Totally forget to put on a song, but it's okay. Alright, so I got 667. I could be wrong. And then I'm going to divide it by n minus 1 because it's a sample, right? So n is 5 here because I have 5 numbers. So 5 minus 1. So, so it's 4. So divide by 4. And I get 166.9. And then the standard deviation is just the square root of 166.9. So I get about 12.92. Okay. What it's going to do, it's going to ask you like, hey, like in your homework, it's going to give you both of these charts, like class A, class B. And then from there, it's going to ask you to, hey, which one is... compare the two. All you have to really do is just talk about the standard deviation. If you notice in the last slide, the standard deviation was 6.34. In this slide, it's 12.92. What does that mean? Well, that means because this standard deviation, 12.92, is bigger. Class B scores are more spread out than class A. And that's coming from the fact, like I said, class A standard deviation is 6.34. Class B has a bigger standard deviation, so that means that numbers are more spread apart. All right, I would copy this. This is a calculator that you guys can definitely use. this will do your variance and standard deviation for you, or variance at least. Okay, so I would definitely copy this down. I will post a link. There will be a link online for it, but yeah, I'm gonna show you guys how to do this real quick. Okay, the marks of 10 students of a class is given to be 0, 4, 9, 12, 25. You have to ask yourself, okay, yeah, I'm finding the variance. Okay, I'm finding the variance. Am I doing a sample or population? So if you guys actually look at the chart at this site, this is the site. On top, it says sample or standard population, right? You guys have to make that distinction. Which one are we talking about in our problem right here? I'm assuming that this is a sample, and the reason why it's 10 students a class. I'm assuming that there's more than 10. I could be wrong, but logically speaking, it should be a sample. Okay? If it doesn't say anything, if it doesn't specifically use the word sample or population, or you can't logically think about it, the go-to move is to go to sample. Once again, if you can't make the distinction between sample and population, go to sample. All right, so from here, what I'm going to do is on top, I'm going to make sure that it says sample. I'm going to click on the icon that says sample. Now I'm going to write down all my numbers: 0, comma, 4, comma, oh gosh, 9, comma, I don't think I need spacing. Yeah, you shouldn't have spacing between like I do. Comma, dang, 0, 4, 9, 12, 25. Sorry, that's a force of habit to do these spaces. 12, 25, 2, 21. 2, comma, 21, comma, 7, comma, 7, 11, 12. Okay, so I'm going to submit my data, and then there it is. The variance is 62.68 about, so the variance is 62.68. If I were to find the standard deviation, then what I would need to do is I would need to square root that. Okay, so that's how you would do it. You would square root that. Okay, so I might as well do it. 62.68. And this is about 7.92. So there it is. We can use a calculator. I would use a calculator. Here I'm doing population of scores. So now I'm talking about population. So back here, what I'm going to do is I'm going to reset. And I'm going to make sure I click population now. And then I'm going to do the same thing. Right? And this time it does ask for standard deviation. So make sure that you're square rooting your number. Got that? Make sure that you're square rooting your number. I'll do this last one for you real quick. Give me 1 second. 7, 8, 6, 5, 6. Okay. So just jump back here. I am on population. The numbers are 8, comma 5, comma 3, comma 7, comma 5, comma 6, comma 6, comma 4, comma 7, comma 2, comma 6, comma 5, comma 3, comma 6, comma 4, comma 5, comma 7, comma 8, comma 6, comma 5, comma 6. Okay, so submit my data. Boom, my variance is about 2.33. So my variance is about 2.33, right? Yeah, my variance is about 2.33. And then my standard deviation would just be, I don't know where I wrote SP. My standard deviation would be the square root of 2.33. So square root of 2.33, and that's about 1.53. And that's it. Cool. So definitely use the site. I will post it online for you guys to use. So know how to do it by hand. The formula is important. Those of you that are going to trig stats next year, population, sample, standard deviation, all that variance plays a really big part in stats. So it's important for you guys to know the formulas. Okay. Besides that, have a good one. Be safe. This is probably, I think I'm going to shoot this out. Yeah. This is probably due on Tuesday. Okay. Bye, guys.